I've got quite an interesting job to do here. It's a sort of job I really like doing. This is a filler cap of something, or a radiator cap. I'm not quite sure what it's off, but it is old. Originally that would have been a casting, so it's been machined out of a casting, and I've got to basically replicate that. I'll have to find out what thread it is. It'll be imperial, there's no doubt about it. It looks sort of 10 TPI-ish. We can measure the thread. Now I'm going to make this out of 2 pieces, because for me to screw cut into a blind hole on this lathe is not pleasant at all. So I'm going to make the brass ring with the threads in, and I'm going to use my new arc joint plasma cutter to trace and cut out that shape on a piece of brass plate, which I can then beat into shape and silver sew that out of there. I've done similar things before, but on a much smaller version. So the first thing to do is find out what thread it is, get some sizes, and I'll have to make a jig to screw into there. I'll need a female thread putting on that bit of bar end, so when I come to screw cut this, I can make sure the screw cutting is deep enough. I don't just want to screw cut it off measurements. I want to make a test piece out of that, if you like, to screw in. And then I've got a piece of brass that I can definitely get the brass ring out of. The lad has supplied that. There is a one in there. It's just a case of finding it, but I'm not going to find it. I'm going to make it a 2-piece affair. He's asked if I can make it sort of rough and authentic. Well, basically, all of my work is rough and authentic. You can see it's got wounds on where it's been hit with a hammer and things. It's called character. You know, you can't replicate that. That takes years for something to get worn like that. Really nice item it is, and I'm looking forward to getting stuck into the job. Right, I've measured the thread. I hope you can see this. The camera focuses. That's a 12 TPI thread gauge. If I can get the right angle, you'll be able to see that it does, in fact, come on bastard features, it does in fact fit in there. So it is 12 TPI. That's better. Right, that's a 12 TPI thread gauge, which fits in there very nicely. To get the job in the chuck, I'm going to have to fit the outside jaws. This chuck wants cleaning anyway, it's gone all stiff. I've actually managed to clean the lathe down before I start the job, and naturally, with a clean lathe, it's a brass job. Just the same as the ordinary jaws, these have got numbers on 1 to 3. Obviously got the 3-jaw chuck. A little bit of oil in there, not a lot because it will spray out everywhere. The chuck does need stripping properly and cleaning. Right, so we'll find jaw number 1, or hole number 1, which is, right, that's jaw number 1 there, number 1 jaw slot. You see the screw starting to come round. Just I hope you can see the screw starting to come round. So we'll find jaw number 1, which is always the last one you pick up. So that goes in there. Feel it enter. And we've got number 2. That one. So jaw number 2 goes in. So again, you see the screw come round, there it is. And that picks up jaw number 2, and then the last one, obviously number 3. As long as it all touch in the middle, that means we've got the job right. See, it is tight to chuck one stripping properly and cleaning. Right. Never fits in the set of jaws you wanted to fit in. One of the issues getting in here with the screw cutting tool, unfortunately, it was the last bit I wanted, and I think the bar's just too small. It is, bastard. A bit of a longer bar would have been better. Well, I haven't got a longer bit at the minute. That's the issue I've got getting the screw cutting tool in, so I'll have to find a longer bit of bar. I think I've got a bit, but it's a lot bigger diameter. Right, so this is what we've got. And that won't grip on the outside neither, so it's going to have to be where we had it. Before I do that, I'm just going to clock this chuck in. There's a 0 there, that's the master jaw, that's the one you tighten. The last one, we'll put a clock gauge on there and see how far it's actually running. I've got about 12,000 out. I can improve that because the chuck has got wiggle room on the back plate. I designed it that way when I made the back plate, so I would dial the chuck in spot on. So we'll dial it in on the inside jaws, it's going to be near enough on the outside jaws for what we're doing. So all we do is simply loosen off these Allen bolts. Right, hopefully you can see the clock gauge there. So we'll find the highest point, which is that one there, and we'll gently tap the chuck across that way. Once again, highest point. And that's pretty good, that's within a thou. Right, we'll tighten them up with that and check it again. Right, that's good enough for John, just under a thou. It's actually pretty good, that has some marks on it, which is giving us a strange reading. That's pretty good. Make sure I've got a really good hold of it. I'll face the centre drills and put a centre in. Then we'll have to work out what diameter I need that to cut the thread on. That's quite a big bit of steel, it's got a lot of steel on it, so obviously I'm not standing right in the line of fire. You don't want that coming out and giving you a bit of a push in the chest. It wouldn't do any favours at all. I don't know what sort of steel it is, it's a bit I've picked up. It's shiny, I think it'll be good quality stuff. Gentle lathe cut, I'm not in a hurry. Like I say, we haven't got that good a grip on it. I mean, that's been cut with a machine hacksaw, and it's pretty good for a hacksaw cut. A little bit of weight on the centre, that doesn't take much. Right, so now we've got it, we can drive on to our hard content really. I've done a little bit of maths here. The thread is 12 TPI, it's Whitworth thread foam. The height of the Whitworth thread is 0.534 inches, which is 1.3 mil. The measurement, like on the top of the thread through there, is 74 mil. And I want 1.3 a thread each side of that. So I need to make it 74 plus 1.3 plus 1.3, because it's 1.3 a side, which gives us 76.6. That's the dimension I need that piece of part to be, 76.6. Put the threads on and it should screw in there. Right, we need roughly 10 mil off that. It's a bit of nice material, that really is. I think the chips aren't breaking, they're coming off nasty stringy bastards. Not nice at all, that's better. I'm going to slow the feed rate down a little bit, see if that helps. In fact, I'll speed everything up. Putting a hell of a finish on with the chips are nasty. Just slightly slower feed rate. A little better. Faster feed rate again. Still not nice, but breaking. Right, we're getting near now. Right, so we've got 76.6. That's what we're looking for. We'll put a nice chamfer on this edge and then put a machine a bit in there for my screw cutting tool to drop into. Plenty of room to stop the tool in. Would you be tempted to put your fingers on this stuff? It really is sharp, it's hot as well. Right, that's plenty deep enough there. Right, it's not too big anyway, and it feels like it's just nice on the start of the threads. And what his job is screw cutting. This Harrison 140 lathe is metric. I need to cut an imperial thread. So to cut the imperial thread, we need to change the gears and the headstock of the lathe. That's the main shaft through. There's a couple of tumbler gears. The top one, that's an idler, and that drives the gearbox. At the minute, it's set up for metric. It's straightforward gear train. And what we have to do is put a compound gear train on to convert it to imperial. There's two gears going here that give a ratio that give us imperial threads. I've got it short, it shows how to set the gearbox up to get whatever thread we need. It's nice and oily in here, that's the way it's supposed to be. All these gears are held on by keys. You can make sure that the keyway on this one's at the top because it has a nasty habit of falling out. We don't want that to be happening. Right, so I'll select the right gears off the chart and we'll put it back together. Right, the top gears are 50, that goes onto there. The 50, then drives a 63, which is this one. That's actually a gear I made. And then we need a 40 on there, which is that one. Another gear that I made. It's a fibre gear. It just happened that I had the fibre. And the idea is if something goes wrong, it'll strip the gear instead of damaging the lathe. And on the bottom here, we'll have a 120, which is driven off that one. So that one drives that one, they're connected together, then that one drives a 120, and that should give us the correct ratio. This thing here is called a banjo for obvious reasons. Looks like a banjo, I suppose. The space that goes on there. Then the 120 gear goes onto there. So that drives that one. You need clearance between these gears. It's nice having them tight or they'll bind up. A little bit of backlash, that feels good. We'll bring that up to mesh into the top gear. Come on, John. Like that. They're noisy, they always have been noisy. It's just the way they are. There is clearance in there. They're just running nice and slow anyway, so it won't do any real harm. I've been going to make a space off of that as long as I've had the lathe, and I still haven't done it. You hear them rattling about, which is what you need. A little bit of lube won't do any harm. That's an important nipple, that one on the end of there. That's what lubricates the bush inside of there. That's it. See, a real filthy operation it is. This is the chart that shows me what I need to do to cut the thread. We've just done the gears, so we'll put a 50, driving a 63, driving a 40, driving a 120. That bit's done. We'll move on to the actual gearbox itself now. Right, we're looking for 12 TPI, which is that one there. So I put the tumbler into that position, which is the third, fourth one along. Those two levers go to the left, and this one here, which is the extra lever that only the certain Harrisons have got, that goes to the right, and that will give me 12 TPI. Right, this is a quick change gearbox. So for 12 TPI, we need to bring the fourth one along. 1, 2, 3, fourth hole, that one there. Then these two levers need to be to the left, and this lever needs to be the right. It's as simple as that. That is now set up to cut 12 TPI. I'll check it again. 1, 2, 3, 4. Both to the left, the magic lever to the right. We'll set the tool up, do a real fine scratch cut, just to make sure we're cutting the 12 TPI. That's a 12 TPI cutting insert. We need to make sure it's nice and square to the job. I know it's on centre 8 because I use this tool quite a lot. We'll check it just to make sure. So we need to make sure it's touching all the way along, and that means that that tool is indexed exactly at 90 degrees to the job. There's two shafts on this lathe. The bottom one is the one, the feed shaft for the longitudinal and the cross feed. This one here is for the lead screw, and that's on a dog clutch, so that's a lead screw engage. On the carriage there's two levers. That one there engages and disengages your power feed, and that one engages the half nuts for the lead screw to do screw cutting. There's a little lever here in and out that controls longitudinal and cross feed. That's in neutral at the minute, so if I pull that lever, that lathe will start to, that carriage will start to move forward like that. Right, so we'll set the tool up, we'll touch the tool off, we'll do a scratch cut and then check it. Touch it off. Let's set a 0 on my DRO. We need 1.3 mil to get the full depth of thread. 0 the cross slide as well. And once I engage these half nuts, the one we just engaged, we'll just reverse the lathe. Right, so we need to take our first scratch cut. That doesn't look right. Right, it is right. It's exactly 12 TPI. I don't know why it looked not right. It just, well, it certainly is 12 TPI. Right, so the procedure is wind the tool out, reverse the lathe, tool back in to 0, plus a little bit cut, lathe into forward again, and on it goes until we get the thread down to full depth. You must adopt the same procedure every time. You've got to concentrate. It's so easy to fuck this up, it's untrue. Right, so taking the cut, stop the lathe using the chuck, R0, the cross slide, wind it out, reverse the lathe, back into 0, plus a little bit of a cut, lathe forward. I've got my DRO now, we're at 1 mil, depth of cut, everything's set up, ready to go. This tool is going straight in using the cross slide, not angled, using the compound slide. This is how these tools are designed to work. Exactly the same. You must adopt the same procedure or you'll fuck it up. This tool is going straight in using the cross slide, not angled, using the compound slide. This is how these tools are designed to work. I'm going to do a spring cut on the same setting. That was no more feed on, that's just taking the spring out of the tool. Time to try things on now, I think. We're getting somewhere near. Settling back to 0 though before we start. Right, starting. I think what's happening is now the diameter of this is slightly too big. So I'm going to run a file across there and then take a little bit more. My DRO is now showing 1.3, so that should be the full depth of thread. Come on, you scum twat. It's good. Right, that's just what I wanted, absolutely spot on. Of course I can use this as a mandrel to machine the ring before we solder it together. So that's probably, I don't know, 2 hours work. I mean, I video at the same time just to make that. Like I say, I do enjoy doing jobs like this. I mean, I make one of them for the, whatever it's off, that'll be here long after I'm gone. You know what I do normally at work, motor cars, 10 years and they're gone. Now we can actually make a start on the cap itself. I'm just going to face this nice and flat. You can see it's a little bit on the pit side where it's been cut with a hacksaw. These little button tools always give a really good finish on brass and aluminium actually. I would really like to part this off. I don't need this much material. We need half of it really, but I can't get a parting tool in there, unfortunately. A little bit more there just to clean it up. job, that's for certain. If I still had the furnace, I would have cast a bronze ring and nail it out of that, but I'm going to have to machine it down to the right thickness and then bore it out. I have to bring it out to the chuck slightly, so I've got somewhere for the screw cutting tool and the boring tool to go through. The other way is to put it in a 4-jaw chuck. That would enable us to part it off, then it would save wasting as much material, which is what I think I'll actually end up doing. Plug it into a 4-jaw chuck and machine it there. Then I won't have a problem with the tool going right through. We'll just square this face up and do it on our own. I should have centre drilled this before I took it out the 3-jaw chuck. Would have made setting it up a little bit easier. That's running reasonably true there now, we'll settle for that. Right, I'm going to try and part it off just to save wasting that big lump of material. The bit that's in the chuck is the bit we're going to be using. I've got the lathe carriage locked off. You have to keep pushing more and more parting tool out as you go. Brass flying everywhere, as you can obviously see. Or managing to save a big lump of material. Unfortunately, it's not big enough diameter. Right, next job is to bore the hole out before we screw cut it. I want to machine a little lead on there, a little taper, the same as that one there's got, just to protect the threads. Right. I think we're happy with that. Right, this is a 12 TPI screw cutting tool. All we need to do is make sure that that face there is touching the job right across square like that, and that puts that cutter at 90 degrees to the job, which is where we need it. The gearbox is set up, so I'm going to touch it off, put a scratch cut through, and then I will check it with the thread gauge just to make sure. I absolutely love the colour of this layout die. I would really like to call that colour. Right, so we'll touch it off. There. Put some cut on. And a 0. Right there, row. Right there it goes. It's exactly the same procedure as the external thread, exactly the same. And so we've got 12 TPI, perfect. Right, gas now. Please, I stopped when I did. I'd bust that slack now. How's that happened, John? Right, I put that piece of brass in I had, and I've screw cut that, and I've actually made it a nice fit just the way I want it. Not quite sure what went wrong with the first one, but we managed to pull ourselves out of the shite as normal. I'm just going to carry on using the 4-jaw chuck, and we'll set this up to machine the OD on that piece we've been playing with. A little bit better now. Right, we need to stop taking jobs. I think that's what we need to do. I need 4mm off there, and then the slight tape I put onto it. Right, alright, let's put a taper on it now. I haven't got the centre in, so I have to be careful as I get towards the end. I'm going to change the angle very slightly. It's a little bit too steep. I'm doing a bit of eyeballing here. It's just cosmetic this now. A little bit less than that. It's starting to look apart. Now so we can screw it off now, which will be the next little issue. And I've got a cunning plan if it won't come off, which I'm going to have to use. Right, so all I'm going to do is part that off. Or at least take a little bit of this away, and it should relieve the grip it's got on the bit of brass. Should do. This is a little bit nerve-wracking, this bastard, I'll tell you. There's a sliver of brass out of there. That should be it, surely. Right. At least something's gone right.